Oh, I was having a little bit of problems.
Oh, okay, someone's watching. Alright, so last time we were talking about well, size. There we go. That didn't help. So if you're here, say something in the chat just so I know you guys can hear or see me. Ugh. Zoom out. There we go. How's this? Whoops. I'm running out of gas today. There's that. This here. See what that looks like. Okay. A little bit down there. Alright. Mess everything up. Okay, now what does it look like? Alright. Not put it down too far. There we go. We can do a there. Just throw me down there. Okay. Now what do we look like? Turn this back on. There we go. Alright, if you guys can hear me in the chat, say something. Oh, anyway. So, since the last time we met, we've had the ER diagram quiz due. And so, a long time ago, apparently. What I'm going to do is I'm going to give you guys feedback on the ER diagram quiz, and then I'm going to make another assignment where you can make corrections. So, with the feedback that I give you, make sure you understand the the basics. Okay. After this class, you might never ever design an ER diagram. You might encounter them. If you make any small projects, any web apps or something, they're useful for that. But just understanding what's happening in the background is what we're trying to get across here. So, that's so weird. So anyway, so I'll do that. I'll make a note here. Whew. It's been just long enough for you to forget everything, right? I do believe the submission is still open, so if you want to try to update your quiz, if you want to take a look at it again and double check it, that's fine before I look at it for feedback. I'd rather you get it done right the first time, so. Sorry. Oh, whoops. That was the wrong desktop. Okay. So, oh, and once you guys have submitted the corrections, I have a video where I go over the entire quiz. So, in between now and then, feel free to ask me any questions if you still want to work on it. What we're doing today is we are continuing where we left off. So I had you guys convert ER diagrams to tables. Oh, okay. Is it like a white noise, like a sand or a beach? I think I have to turn off one of these microphones. Oh. Okay. That's there. Oh, I think it's because I set it to the default in here. I'm going to check this. I'm going to open it on my phone to see what it sounds like. Okay, I was getting this sound in the last stream. Somehow I was able to fix it. And I think I have to change one of these. Not the other. Let's try that. See if that does anything, and then we'll try. Oh, I think that fixed it. Now you can't hear me though. Can you hear me? I'll just have to talk loud. Oh. This is on the wrong setting. Let's see. Is that louder? Okay. Well, do say something if you can't hear me, and I'll keep checking here. All right. So last thing we did was converting our ER diagrams to tables, which involved creating the fields for each entity. So let's pull that PowerPoint back up here. Fields, because we left off with field properties. And so you'll see as we move on through database design process, things get complex quickly, but if you did the previous step correctly, it should keep things working. And if you did the earlier stages correctly, then it will be easier to go back and fix things. But remember, if you change any fundamental part, add an entity, create a new relationship, you have to go all the way back to the ER diagram and add those in. And then you can recycle a lot of the tables you may have created before, and then you have to create new tables for any many-to-many relationships and any new entities that you've added. Then you have to decide the fields for those. And then what we're going to talk about today is for each field that you're going to create, you have to set its field properties. And so from ER diagram that represents the database down to rectangles that represent an entity, the entity has fields inside of it, those fields have field properties. And so you can see it quickly branches out into a lot of work. Okay, can you still hear me? Okay, good. We talked about data and information, We talked about improper fields. We're down to, ooh, I skipped over views, which I feel like doesn't really make that much sense right now. It'll make more sense when we start working with SQL, but every one of our entities in our ER diagram represents an actual real table, so data that's being stored on the computer to the hard disk permanently, or at least in such a way that it won't disappear when we turn the computer off. So I guess it's not permanent, but semi-permanent, I think is what it's called. Anyway, it's readable and writable, and it persists without power. All right. So besides real tables, we also have fake tables called views. Okay, so there's a couple different ways that you can use views. You can use them to basically, when you're writing queries, you can use them as a shortcut to store queries, which right now maybe doesn't make any sense. Ultimately, what we're going to be doing with this database, or any database, is trying to organize the information in the optimally efficient manner so that we can quickly ask it questions and it can give us answers. All right, a query is just a way to ask a database to give you some answer. Okay, so an example of that would be data mining, I guess, is a very popular term and is used a lot in things like marketing and product development and basically just making any kind of decision whatsoever. Because the more data you have, the farther into the future you can estimate. Okay, which can be dangerous, but that's for the business people to think about. We just set up the database so that they get the information they need as fast as possible. And since databases scale up to be so large with so many records, some things that we do in this class that you'll probably find out when we have assignments and stuff, you'll find certain ways to do things, and this is just like programming. There's multiple ways to get the same answer. Some are just way better than others, and that is exemplified in querying a database, because when you have to pull 1 billion records, because you're Amazon and you need to find some data about how many raincoats you sold April of 1954. I don't think they existed then, but you can ask the database that, and that's what the second half of the course will be. How do you figure out how many raincoats Amazon sold a decade ago? Who bought them? What states were they in? What countries were they in? Does Amazon deliver internationally? Okay. Literally any field that is stored about any of the entities you're using is something you can query on. Okay, you could grab everyone in a certain zip code. You grab everyone named Smith. If you were Amazon, you could find everyone named Smith that bought 2 raincoats within the past 5 years. You can get that specific. Now, why is that useful? Well, again, that's more of a business question at that point. But what I said earlier is that you can gather a lot of data and figure out patterns, basically. Now, if you watched, this reminds me, if you watched the video I posted, Big Data in the Future, a guy talks about it, an example of data mining at a very low scale. Anyway, it was just noticing a pattern, but in the US, it was accepted that apple pie was everyone's favorite. The most favorite pie in the country was apple pie. So apple pie sold a lot. Okay, when production and capitalism and marketing or whoever decided to start selling pie by the slice in stores, they noticed that not as many people picked apple. They picked different flavors. Okay, so what they figured out was apple pie wasn't everyone's favorite. That's what everyone was willing to settle on. And you could actually sell more pie if you chop it into pieces and sell it a piece at a time, because then you can target and figure out what people's favorite pie really is. And so that's it may be hard to understand why that is valuable information, but you can just apply that to pretty much anything. That's why, collecting and storing data is so valuable these days. Everything we use does it. Okay, let's see if anyone's complaining yet. Nope, we're good. Okay. So back to the PowerPoint. All right. So anyway, really got off topic there. So a view isn't a real table. It's just a virtual table, which means it's not real. It only exists. When you need it, it gets generated from other tables. Okay. So an example of this would be if I had a one-to-many relationship between I can use Google Sheets to illustrate this. All right, let's say I have a customer table and I have a, company table. So we keep track of customers and we keep track of what companies they work for. Maybe they have corporate discounts or something. So a customer can have a customer ID, first name, and last name. And we said this is a one-to-many relationship. So let's think about which way we want that one-to-many relationship to go. Is that what I think it is? Or are they just drinking water? Okay, so a company will have, let's call it a corporate ID, and a name. I like to bold the field names, just so they stand out. What I'm teaching you in this database design process, or what I'm teaching you, is partially my own style mixed in with what the best style is, and then I cut out a lot of the more complicated theoretical parts and give you enough to where if you wanted to design a database and use it for a web app, you will have everything you need to do that. Okay. So anyway, we have this. And so we have a one-to-many relationship here. And do we want that to be one customer can be part of many businesses, or a business can have many customers or employees under it? What do you guys think? If it's one-to-many, which one makes the most sense to you? Because this is part of it, is just being able to keep it straight in your head. So if we go with one on this side and M on this side, what is that going to look like? I'm just doing this to kind of highlight the relationship. So this is how you read this is a record from here can be related to many records over here. And a record over here can only relate back to one record over here. Okay, that's what this layout is saying. So if we actually just say it in plain English, we're saying a customer can be part of many companies, but a company can only have one customer. That doesn't really make any sense at all. So we'll flip that around. And now we'll say it again. So in this case, a customer can only be part of one company, and a company can have many customers. You know what? I'm going to call this employees. Customers under a company doesn't make, it's confusing. Now why does this keep changing? Okay, there we go. So let's put some records in here. 1, 2, 3. Jay, Bob, Sally, Smith, Jones, Lazarus. Put up some companies here. 1, 2, 3. We have Amazon, Google, and MySpace. Does that even exist anymore? So, how do we know which employee is part of which company? Hopefully you guys know the answer to this because it was a major part of the quiz in the last assignment. If not, you know, it's never too late to learn during your life. So remember, once you know the relationship and you've decided on the primary key, for a one-to-many relationship, you always take the primary key, so you always take the primary key from the one side and you put it in the many side. And it'll only work out that way. So if you're a trial and error person, try it one way. If it doesn't make sense, try it the other. Eventually you'll get it. Oops, I actually didn't want to cut that. Just wanted to copy it. Okay. Let me check the chat here. Okay. So now, this is corporate ID in the employees table is no longer a primary key, it's a foreign key. Okay. And that allows us to see which company each employee is part of. So in this case, Jay Smith is part of Amazon, Bob Jones is Google, and Sally is part of MySpace. Okay? What if we added another person Justin? That took way too long to think of a name. All right. So, what company should Justin work for? So, in terms of what values you're allowed to put here, not, you know, just, hey, Justin Smith, he probably works at da-da-da. But where, you know, how do we represent where he works? We just use the corporate ID of the company. So let's say he also works at MySpace. We would put a 3. And the reason I wanted to make it, you know, point that out is foreign keys have nothing to do with being unique. They're only to represent the relationship. the data inside of the foreign key, to you as the person, or as the person using the data from the front end, it's just useless information. Okay. And so you can see this layout will allow us to scale, as many employees as we want, and then we can add new companies, and then we can put each person in their appropriate company. All of this to say what a view is. Okay, so if I have my data stored in tables like this, I could print out, and someone wants a report with information about employees and the companies they work for. This might actually be a database for like a job finding site, potentially. Anyway, we need to look at, if we wanted to see that information, which employees worked at which company, what we do is we think about what fields we want to see in that result. Okay, so if we want to know who it is, we probably need the CID. Why do you think that is? Probably need the first name. Probably the last name. Do we need to put the corporate ID? What does the corporate ID represent? So if we just printed the information out of this table, it would look like this. Well, it would look just like this. I don't know why I'm copying it. And so if you gave this to someone, what would be the problem with this? There's a huge problem if you just presented someone with this data. What do you think that is? Well, unless that person has memorized every corporate ID in the database, and there could be thousands or millions, this is going to be useless information for them, right? So we don't even need that in this result, because all we care about is finding out which people work for which company in this report. So instead of corporate ID, we can just, remember that ties it to the actual company name as the corporate ID here. We can actually just pull the name field from the company table. Should have named this better here. Company name. And actually, you can't have spaces in here. Actually, you can, but it's annoying, so. Putting spaces in values that are going to be interpreted by a computer is a dangerous endeavor, because you have to understand how the computer interprets those. So if you just don't use spaces, you're safe most of the time. All right, anyway, if we put this information together like this, so we're grabbing these, I lost Jay's last name here. That would pull out just these three columns and put that in the result. And then it would only put the field from these three rows here. Okay, and so now this is something that looks much easier to interpret, right? So now I have 1, 2, 3 tables. All right. Do I want to actually store all 3 of these tables? Why or why not? So think about what does it mean to store data in a database? So it has to do with transferring the data from memory, potentially over a network, and to the hard drive. So a physical piece of hardware where the data can get stored. And the hard drive is usually the bottleneck in the whole thing. Sometimes it's the network. It used to be the network more often than not, but network speeds are much better. Anyone remember dial-up? All right, so one of the most important tenets of designing a database is reducing redundancy. And so I believe we mentioned this in the previous, either one of the PowerPoints, but we don't want to store the same values over and over. Why not? Why don't we want multiple copies of this? Why would it be very detrimental to my database to store the information in all of these tables into 3 different tables? And maybe we'll call this one person report. I can name the table that. Okay, so if we stored this information, it would be redundant because we already have it stored in other tables. So we don't want to permanently store this. And it's not that difficult for the computer to find the information and put it together. All right, we'll talk about something called an index later. It's probably coming up in the slides, but it might not be till later. And it's a shortcut that allows you to pull partial records and get data much more efficiently from a database. But it's kind of an advanced concept, so we'll get there. So instead of storing this table, we can create a view, all right, which it's not a table. It's the set of directions to put the table together. So with SQL, we would write commands to the computer that would say, pull this information from the employees table and pull this information from the company table and stick it together, spit it out to me, and then it erases it. That way it never has to go back to the hard drive to get other information. Because what if we did want to get the corporate ID? We would have to grab that part too. All right. I should put that in the slide. I swear I understand this stuff more every time I go through it. All right. It's getting scary. It's getting harder to teach. All right. So the important thing about a view is it's not a table. It's a virtual table. And so it's a table just like I'm a virtual billionaire, or I can virtually fly. It's just not real. All right? And so you can think of it, and we'll use these in SQL, but it's just a set of directions to put the table together, because it's much faster for the computer to put this together than it is to go grab the information in multiple places. All right. And then why did I do that example when I actually have one in the slides? Okay, so I talked about using views to put data together to, generate a report. And the example, may not have been clear because there wasn't that much data. But look at this Walmart receipt. Okay, this is a report the data is pulled from a database. Okay, it has primary keys. It has different fields. You can take a look at any sort of artifact that contains data like this and convert it into an entity, or so when designing a database, this would be something that you would look at. Like if you were designing a database for a store and they hand typed their receipts and had to look up the prices of things, then they would show you what a receipt they had looked like, and then you could take that and build them a better system that will keep track of the prices for them and the inventory and all of that. Okay, so let's just look here at this picture of a receipt a little bit closer. Okay, and then see if you can think of some fields that are represented on this receipt. Think of some names for those fields. Okay, there's a ton of them. This top part with the Walmart and the motto down here, they have a lot of mottos. Do you know what Walmart's motto is? Yeah. Companies have to keep changing their logos and their mottos every time someone gets offended. So they're always changing them to try to stay out of the public eye negatively. All right. Used to be any publicity was good publicity, but now with the internet, you make a public mistake, it haunts you. Okay, there's your warning. So that all that to say, this is not a field. This is probably just a static value they put in there. Okay, this phone number could be the store number, or it could be tied to this manager. And so this is the job title and name of the employee. Here's the address of this Walmart location that gets pulled from the database. And so what about each line here? What are these? What does this represent? So we've got product names, and you can see they're shortened there's probably a lot of reasons. Maybe just to make it fit on the receipt better. Seems like a good reason to me. And then they have these. So this tells us what the name of the product is. This middle part with all these numbers is probably the ID number for that product. All right. And so it looks like these. There are also some fields here. I can't interpret these. There's ST, OP, ST number, OP number. I'm not sure what these represent, but they would be fields. Or I think some of those might be calculated fields. Who knows? So besides just the product name, we have the product ID. I'm not sure what this F is. That's a field. Looks like a Boolean field unless they have different letters you can put there. Okay. And then what is this last one? This is the price. And so it's interesting to me that here they bought 2 paper gift sacks. And so here they have the same name, they have the same ID number, and they have the same price, but yet they still list 2 of them on the report instead of saying paper gift sack 2 at 25 cents, like they do down here with bananas, which it might be a little bit different because you weigh them, but with quantity of an item, the price up here is based on the quantity of the item. The price down here is based on the weight. But with the weight, they calculate out the price, and this would be a calculated field. So, when the cashier, or I guess at a self-checkout, whenever you weigh the product, that gets stored as a sale, potential sale of that product at that weight. Okay, and then to look up the price per pound, multiply those, and so it looks like, where's this 56 coming from? 1 pound divided by 0.56. Well, not sure where that's coming from. Oh, and then we have X's and N's over here. Who knows what those are? Bars. So it looks like bars and bananas have an N. And it looks like the F here. I'm noticing the pattern now. It looks like the F's represent food, which may be tracked for people that get EBT benefits, right? Because they need to separate out which transactions qualify for EBT payment and which ones don't, so they can accurately collect, the money from the right sources. All right. All right. There's another example about views, which is very similar to what I did, so you can look at that if you want. Okay. Let's talk about some of the terminology here. Let me see if anyone's chatting. Nope. Okay. Let's talk about these integrity-related terms. Okay, so what is integrity? Well, let me turn on my definition thing here. If you don't know the meaning of a word, you should make it a priority to understand that. Having a broader vocabulary is extremely valuable in communication, and I guess mostly communication. Okay, we don't need that anymore. Where were we? Okay. So, does this work in here? I don't know why value got jammed in there. Integrity. Quality of being honest and having strong moral principles, or the state of being whole and undivided. All right. So we're not talking about whether the database is honest and has strong moral principles, though the honest part does talk about, or does tie into the second part where it says the state of being whole and undivided. So keep that in mind as we talk about these topics. All right. I think I labeled this slide wrong. I think that's what's going on. And so I was autopiloting into the wrong topic. Okay. So ignore everything I just said. Actually, understanding integrity in terms of databases is really important. So just so you can understand examples and ask proper questions if you need to, like any kind of terminology. Okay, so anyway, there are three types. There are three types of elements that are related to integrity as part of a field. Okay, let me reword that. So we're going to look at how fields have integrity within a database, or how they maintain integrity. So first is general elements. So in the database, we keep track of information. Every field has a field name. Okay, we can't have any fields without a field name. All right. We can't have any fields that aren't part of a table. All right. A lot of this stuff is easy to take for granted because it's it's mostly impossible. But through some very bad misunderstanding, you could try to implement things in this way, and it wouldn't be good. All right. So these are kind of descriptive elements of fields. All right. I failed to find a better word because here's just, description is one of the general elements. There are physical elements. So this refers to how it affects the computer. Okay. Is this going to be a field that takes up a lot of space and is going to be slow to transfer data between, or is it going to be small? Right? There's not a right or wrong answer. There is a best answer and a bunch that aren't as good. All right. There are wrong answers though, but I'll tell you how to fix it if you need me to. So those are data type. And why would data type affect when we're talking about physical elements of fields? It's the closest thing that we can understand in the real world. So data type is represented in the computer differently depending on which data type you use, right? If you store something as an alphanumeric data type, it takes up a certain amount of space and is stored in a certain way. Numeric values are stored differently. And there are a ton of different data types that we'll take a look at. All right, but it is important to understand the difference between numeric and alphanumeric and what you can and can't do with those. All right, other things are length, other physical elements. So you can set a data type to alphanumeric, and then you can limit the length of that field. What that allows the computer to do is when it's reserving space for records, it won't have to save the max length for that data type. It'll make it the size that you specified. So that allows you to add your own kind of promises or integrity to the field. And it would, if you don't need the space, you need to tell the computer that, or else it'll do it. Because if you don't say it, that is like telling it to use the default, which is just the maximum amount. So it could just take up the maximum amount of space, and a bunch of that will just be dead space, a waste of space. All right. Another example of a physical element would be display format. So how do you want to display your decimals? How do you want to display monetary values? How many characters do you want to display in a string? All right. So, and how do you want to display or format your dates? Because around the world, people format dates differently, and I can't think of anything off the top of my head, but I'm sure a lot of really bad things occurred due to misunderstandings about date. Kind of like mistranslating measurements from, inches to centimeters, or interpreting inches as centimeters, or vice versa, because that caused some people to explode. So make sure you use the right data type. Okay. The logical elements allow you to specifically control specific properties of a field. So if I was storing, I had a pet store and I was storing inventory about what pets I had, would I allow negative numbers to go in those in the quantity field? What would a negative dog be? So we can tell the database not to accept any values less than 0. And so now we have our own, we've applied our own integrity to limiting what can go in that field. And once we set these, once you change these elements of a field, they're stuck that way, because as soon as you implement the database and it starts filling with data and it starts being used, I think I've said this before, it's kind of too late to go back at that point. It would just potentially cost more money than you've already spent. So a lot of companies have failed implementations involving more than just databases, but all kinds of technology, because they did not plan properly. Okay. So we have required values, range of values, default values. So if someone doesn't enter a value, we can set a default value, so that way our field isn't null, which we talked about that can cause issues. All right, so how do we change these elements? Well, we use field properties. And in MySQL, you just use the name of the property and you give it a value, almost like in CSS. It's just a property value pair. That's how you set the properties of most things. You have a property name. The computer knows how to take that property name and apply the value to do whatever that is supposed to do. All right. So let's take a look at some of the field properties. The first one is, what type of key status does this field have? And so I only put 3 options here, but there's actually 4. Is it actually there's 5. Is it a primary key? Is it a foreign key? Is it neither? Is it both? Or is it a composite primary key? All right. So I think in MySQL, we'll get there, but I think you just set multiple. Well, we'll get there. I think it involves SQL syntax that we'll learn later. Okay. So we always need a primary key. Remember, that's if you didn't have a primary key, your data would be ruined quickly, because you would have so many. You couldn't prevent duplicates if you didn't have a primary key, or if you did, it would require that you query the entire table every time you wanted to do an insert, and that's just too expensive. All right, so we talked, data type is one of the field properties. So moving forward, we're going to add a couple more that I want you to be aware of. The date data type and the Boolean data type. Boolean simple. That means the field can only have two different distinct values. Kind of like binary has 2 different distinct values, 0 and 1. and then from that you can build any other number. All right. Date as a data type is kind of interesting. How to represent a date in MySQL. Oops. Let's look at the date type. So if you take classes with me, you'll notice I go to the I use a lot of resources as I go. It's a really good habit to do that because you can't take for granted that whatever you're using still exists, or at least in the same state that you last used it in. So if you're going off of purely the textbook, well, in this class, you don't even need to open the textbook. It's so outdated. Database is a well, when you're actually going to build and implement database in any kind of computer topic is untenable in textbook form. So unless you're using a resource that can dynamically update, like the official documentation, how will you know what you can and can't use? And so you always have to stay on top of things in that way. It's not like you constantly watch the tech blogs for new functions added to SQL. I mean, there are some people that are like that, but just look up what you're trying to do, and someone may have made an easier way to do it. Okay. That's almost like iterative learning. You're going to have to keep relearning the same things as they change slightly over time. Okay, anyway, this doesn't have... Oh, maybe it does. Okay. When does computer time start? I can always have a hard time. I need to put this in there. Okay. So, talking about data types, how are they? So remember, anything that you're going to represent in a computer needs to be able to be represented by a number. Okay, so music can be represented by a number with sampling. Images can be represented by a number with coordinates and color codes. All kinds of things. Virtual space, and also dates. Well, a date is a number anyway, but minutes in terms of computer time may as well be decades to a computer. Okay, so if you look at your... Did they take away pause break? Well, if you look at the properties of your computer, so if you're on Windows 10, you can go to your File Explorer, go to this PC, and go to Properties. You'll see that your processor has a number here. Okay. This represents, in layman's terms, it represents how fast the computer can process, or at least the CPU. All right. And you can break it down further into what it actually represents, which is a hertz. That's what the HC stands for. In terms of a signal being sent along a bus or a copper wire, or copper circuitry. Inside of the CPU, it can perform this many instructions. Okay, so 2.6. If it was 2.6 hertz, it could perform 2.6 instructions per second. With gigahertz, it's actually 2.6 billion. So in the, let's see. So hertz is representing, used to represent frequencies. Okay, and so when signals travel, you can when signals travel through wire, yada yada, you can represent that with a cycle. So it starts at the top, moves to the bottom, and during one cycle, the CPU can do 2.6 billion instructions or steps. And so what that means is when you write any kind of code, we write in high-level languages at this point in time. And so you almost don't even need to understand binary anymore. But if I wrote, a command to make the computer print something to the screen, okay, that gets broken down into 1.5 million steps. You have to communicate to the monitor to tell it to update these specific spots with this specific pattern. And so that could take, a few cycles to set up the communication between the two, and then to process. Anyway, it helps a lot if you understand how a computer works. So I do talk about it a lot in this class. So I'll talk about it more later. All right. So that's, anyway, I totally forgot to tell you why I made that big deal. Okay, so to represent date inside of a computer as a number, let's see, different languages I think come from different times. But instead of keeping track of the date like we do as humans, where we have a day, Monday is the first day of the week of 7, September is the 9th month of 12, 28 is, how many days, here's how many years, here's how many hours, minutes, seconds, and then if you're crazy, you can keep track of milliseconds, I guess. As a human, unless you're doing like some kind of engineering or science, milliseconds don't really matter to most, non-specialist people. It's a very specialized type of time. Anyway, milliseconds are very important to us in database, because if you change a query, so if I ask a database a question in 2 different forms, and one is even like a microsecond faster than the other one, all you have to do is understand that you're eventually going to have to scale that up to a bunch of records, so that 1 microsecond could become 1 million microseconds. And so that's why you can see I make such a big deal about the database design, because it'll help you avoid situations where you will make inefficient queries and have redundancy, all of those things, which you can ask any professional, they've probably seen it. It's rampant. Okay, anyway, I still didn't say it, but time is represented by the number of, I believe, milliseconds after the chosen date, which I think it's better on Wikipedia. What is this called? computer, epoch, Wikipedia. Whenever I don't understand something, the first thing I do is go to Wikipedia to look, because it's going to tell you in layman's terms. And then, you can go to the references and read for yourself where they got that information, but don't take it at face value, but it really can help you understand things. All right, so let's see if we have date. Actually, let's look up MySQL so we can see when. Nope. Okay, SQL. There we go. So here's another. So we're using MySQL in this class, or we will be using it, and that's what we're focusing our design for. But there are other popular databases that have better security features and optimizations. Usually they coexist. These different options coexist because they offer different things. So, like for example, it says PostgreSQL emphasize the extensibility and SQL compliance. Okay. Anyway, you could read all about it, but even more so than programming languages, once you learn a query language, and you understand what all you can do, it's very easy to switch between them. And when I say easy to switch between them, I mean if you have a job where you're using MySQL and you get a job where you're using PostgreSQL, it shouldn't be that big of a deal for you. Now, if you're using both on a daily basis, you would probably go insane, but or maybe you would get really good at knowing the differences. All right. I'm sure some people have created translators too. All right. Checking the chat. All right. Let's see. I think I went over time here. I think I'm about 5 or 10 minutes over time, so since I didn't finish the field properties here, I'm going to push that one back. Where did I have that? Adding field properties to our field. So I had that due on October 2nd. I'm going to push that back. Okay. I have so many resources and tools that I put in these courses, and then sometimes they break and they disappear. So if you ever encounter that, I guess you get a pass on that assignment because we can't do it if the tool's gone. Okay. Anyway, I'm going to push these dates back for field properties. The ER diagram homework 2 you can do on your own because you're just following these videos. But I'll push back the fields because I don't want you to start that until we cover it fully. All right, last chance to ask any questions. Let's do another week on that. I might have it on Friday. Here, we'll go here. This is a Monday class. Okay. I think that is a good stopping point for now. We're about halfway through talking about field properties. We'll cover the rest and then we go into more detail about each one so that you understand why it's important. Not only how to use it, but why we care to store this. Because there are a lot of specific cases where you can't do things without proper field properties. You can't properly represent the processes and data storage of an organization and their data needs without understanding the underlying reasons for using field properties. And there's a lot of different ones. And some of them we just never care about for our situation, and some you have to do every time. Okay, so we'll talk next Monday, and between now and then, if you have any questions, make sure you email me, and if you need, we can do a one-on-one Zoom meeting. So thank you very much, and have a good day.